What's up, guys and girls? Okay, another session, another problem, and another hat. We have problem 8 here. Suppose f prime at x is a differentiable increasing function for all x. Whoa. In each of the following pairs, which number is bigger? Okay, I don't care about that sentence. Let's go back to this first sentence. F prime at x is a differentiable increasing function for all x. What could our function look like? If the derivative is always increasing, that means the derivative is always getting, from your angle, steeper and steeper and steeper and steeper. That's exactly what concave up means. Okay? I drew you guys a graph. So here's an example of a function that is concave up. And I know that because no matter where I start, if I move to the right, if I move my x to the right, the slope is increasing, 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 increasing. That's why this is just a parabola, of course. That's why it's concave up everywhere, because as x increases along the x-axis, the slope of the tangent line increases. So our function has to be, it doesn't have to look like a parabola, that's for sure. Oh, I have another example. Yeah. Let me show you this one. E to the x here. I'm going to get these ones off there. E to the x is another one that's always increasing. The slope is always increasing. Okay, so it could look something like that perhaps as well. Okay, that's also always concave up, by the way, and does not look like a parabola. So that's a cool example there. Okay, so let's go back to the question now. Now, I just wanted to form a little bit of intuition there, and now I feel like we can get into this stuff. Okay, so that's kind of what I say here. Before we even start, this is me getting emotional. Blah, 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 answer, blah, blah, blah. We did all that. Okay, now we can tackle the questions. Part A, what's bigger, f prime at 9 or f prime at 10? What do you think? F prime is increasing for all x, so not much more to say about that. Email me if you have questions on that, okay? Now, what's bigger? Okay, weird, double derivatives or zero. Frig. Okay, what does the double derivative mean? The double derivative is the rate of change of the first derivatives. Well, what's happening? They're increasing. They're always increasing. The first derivatives are always increasing. That's what this says. Okay. We also kind of covered the concavity already. And second derivative represents concavity. The sign of the second derivative tells you whether you're concave up or you're concave down, because if the second derivative is positive, that means your first derivatives are increasing. Just as in if your first derivative is positive, that means your original function is increasing. Right? It always works at down level like that. It would work for the fifth derivatives or the 500th derivative. If the 500th derivative was positive, that would mean your 499th derivative is increasing. Okay, there's nothing special about the second and the first derivative and increasing and decreasing. It's all derivatives. They all work like that. So is this thing going to be positive? It's only positive if the first derivative is increasing, is it? I don't know. Then it's okay, and then you compare that to 0. Now this one's the best one. This is the best one. I did a Desmos for this. Okay, so let's first, what we want to do is, I'll just let you see this. This one's important to visualize. It is very important to visualize. This is the most important question, part of this question. Okay, it is a very good question. We need to make sure we understand what each of these things we're trying to compare look like graphically. I drew up a graph. Come look at my Desmos. Okay, so where's my graph? Okay, so I don't know how to both overlay these at the same time. So keep in your brain this first one. F at 9 plus some small change in x. Okay, so let's look here. I'm going to change this function here to this one, just so it's a little bit easier to see here. So f at 9 would be, I guess, right there. Let's change this to 9. Boom. Okay. F at 9 plus some small change in x. That's talking about the original function, right? That's talking about the blue function here. So like some small change in x, let's call it 1 box in this case. That would give me the value of the blue function. Okay? Not the red function. All right. That's what this one means. Now let's compare that to f at 9 plus f prime at 9 times delta x. F at 9 is this height, the one where the purple dot is right now, plus the slope times some small movement in x. And we'll say the small movement in x is this one here. Okay? The slope times some small movement in x, that will give you the red. That ensures that you stay on the red graph. Right? If you did slope times 1, then that would just be, you know, rise over run. That would just bring you to 10 here. And then up there on the red graph. So if you go only a delta x, you're only going to go a delta x portion of the slope. That brings you up to red line. Make sure that you sit and think about that for a bit. Make sure you understand that a f prime at 9 times delta x forces you to stay on the red line no matter what. Okay, that's what that second one is, that's what that's talking about. So now if we want to compare these two things, well, this is on the original graph. This is on the tangent line graph. The tangent line can't continue to increase its slope, so it can't keep up with the original function, which is always increasing. The slopes, its slopes are always increasing. Okay, so use that information to answer that question. And that's it. As always, if you want me to personally help you pass your course, check out the description. Check out the description, and I will help you. Have an awesome day, and until next video.